All right, this is the study guide for 6.3, 6.4, and 6.5. So the first two questions here ask you to find the inverse of each function. So step one was if they had written it in the form f of x equals 6 to the x minus 4. Step one would have been to change the f of x into a y, okay, which we don't have to do here because it's already a y. Step two is to flip the x and the y. So we're going to make this x equals 6 to the y minus 4. Right, and then we're going to want to turn this into a log, right? So we're going to have to add 4 to both sides. So we're going to get x plus 4 equals 6 to the y. And then if we remember, if we have y equals b to the x, right? Or you could have it backwards, b to the x equals y. Then we're going to get log base b of y equals x. And again, you can write it the other way as well. You could say x equals log base b of y. Okay, so this is going to be very relevant to everything we do here. All right, so we are in exponential form here. So my y is x plus 4, my base is 6, and then my x is y. So a little confusing with the x and y's, but we're going to change it to log form. So it's going to be y equals log base 6, x plus 4. Because otherwise it's, it might think it's just the x is the only thing in the function. Okay. So the next one, we're going to do the same thing. We're going to swap our x and our y. So we get 4 to the y minus 6. We're going to add 6 to both sides. So we get x plus 6 equals 4 to the y. And then again, we're going to convert it into log form. So we're going to end up with y equals, and then it's log base 4 x plus 6. And that would be the inverse of our original function. Okay. All right, wonderful. Okay, next one. We're going to rewrite in exponential form. So again, our base is 6, our y is 36, our x is 2. So if you need to, you got to go back in the video, look at those equations, write them down. But we're going to change this to 36 equals, the base is 6, the x is 2, so it's going to be 6 squared, right? And that makes sense. 6 squared is 36, so that checks out. Okay, and then over here, we're going to have 343 equals 7 to the 3rd power. And again, that checks out. 7 times 7 is 49. 49 times 7, 343. So that one you're just changing from log form, log base b y x, right, into x equals, y equals b to the x, right? We're just going between log form to exponential form. All right, these ones we're evaluating. So we can think of it as 2 to what power gives us 32. And that one should be 5. If you can't come up with it, though, we can use the calculator, right? So we can type in log base 2 of 32, and we get 5. Same thing over here, right? 2 to what power gives me 64. That's going to be 2 to the 6th power. So this would be equal to 6. And again, if we want to put it in the calculator, we would have log base 2, 64. 2 to the 6 is going to be equal to 6. All right. All right, next up, we're going to solve. So we can't solve in log form here, so we need to convert it to exponential form. So it's going to be x plus 3 equals, the base is 6, so that's going to be 6 to the 0 power. 6 to the 0 power is 1. So we're going to minus 3 on both sides, and we get x equals negative 2. Okay, if we want to check our answer, we can plug it back in. So we could do log base 6, and then negative 2 plus 3, enter, and we get 0. So we know we have the right answer. Over here, same thing. So it's going to be x minus 8 equals 7 to the 4th power. That's going to be a big number, right? 349 times 7, that's going to be in the thousands. So let's use my calculator. 7 to the 4th, 2,401. 2,401, and then we're going to add 8 to both sides. So we get x equals 2,409. Okay, if we want to check our answer, we're just going to plug it back in. So we have log base 7, and then 2,409 minus 8. And that gives us 4. So we've checked our answer successfully. We're good. All right, let's go to the next slide. Describe the transformation. Okay, so again, I'll just use f of x equals a, right, x minus, log x minus h, right? Log b, the base, right? And then x minus h plus k. Okay, h is your horizontal shift, right? If we remember. So h is horizontal shift. K is vertical shift. And then A is your stretch or shrink. Okay. A could also be a reflection. If it's negative, it would be a reflection across the x-axis, right? Or if there's a negative on the inside, it would be a reflection across the y-axis, but we're not going to worry about that for our purposes. Okay, so the first one, A here is just a 1, right? There's nothing in front, so there is no stretch or shrink. H here is going to be 2, and K is going to be 4. Okay, since A is 1, it's not a shrink or a stretch. Since H is 2, this is going to be 2 to the right. And up 4, this is going to be 4 up. Right, so again, H is positive 2 because the formula is x minus H. So the H is just the positive 2. Right, over here, again, A is 1. Okay, H is going to be negative 3 because, again, the formula is x minus H. Right, so x plus 3 is really x minus negative 3. Right, that's what x plus 3 is. It's x minus negative 3. So negative 3 is H, and then K is negative 7. So no stretch or shrink. We're going left 3 and then down 7. All right, more inverse ones. So 1 and 2 are inverses. 11 and 12 are also inverse. So first step here is we want to switch our x and our y. So I'm going to make it x equals 5 log base 5y. Okay. I got to get it into the right form here. So I want to get it to look like this. Oops, this should be x, right? Again, it doesn't matter what letters are which, but you know, this is the form we're going for. So in order to do this, to get log base by by itself, I need to divide both sides by 5. So it's going to be x over 5 equals log base 5y. Okay, now I can change this to exponential form. Y equals b to the x. So I'm going to get y equals, the base is 5, and then the power is 5 divided by x. The exponent is 5 divided by x. And there we go. Next one. We're going to switch the x and the y. Okay, we need to switch this to exponential form. So this is going to become negative 3y equals 6 to the x. And now we got to get y by itself. So we need to divide both sides by negative 3. So we're going to get y equals, I'm going to move the negative out front. And then a lot of people tried to make this 2, but you can't combine the 6 to the x and the 3 because they have different exponents. Okay, so there's no way we could combine those. So that's going to be my final answer, right? The reason we couldn't divide by negative 3 first is because it was inside the log function, right? Whereas over here, right, the 5 is outside of the log function, so that's why we could divide by 5 on both sides first. The 3 over here is inside, so we couldn't do it until the end. 13 and 14. Okay, so I would simplify all of this first. So let's see, I'm going to do log base 4, and then this is really x to the first. So when you have an exponent to an exponent, you multiply. So 1 times 2 is 2. 6 times 2 is 12. So it's x to the 12th, x squared, y to the 12th. Okay, and now we're dividing here. So that means when we expand this, we're going to subtract our log. So we're going to have log base 4 x squared minus log base 4 y to the 12th. So that's the quotient rule. And now we're going to use the power rule, and we're going to move our exponents out front. So this is going to become 2 times log base 4x minus 12 times log base 4y. And that is our expanded answer. On the next one, again, this is v to the first. So u to the 4th to the 5th is going to become u to the 20th. 4 times 5 is 20. And then v to the 5th, 1 times 5 is 5. Because when you have a power to a power, an exponent to an exponent, you multiply them. All right, now we're multiplying here, so I'm going to add the logs together. So it's going to be log base 2, u to the 20th. And then this time plus instead of minus. Log base 2, v to the 5th. And then we're going to use the power rule. And we're going to move our exponents out front. So we get 20 times log base 2 of u plus 5 times log base 2 of v. And there's my answer there. All right, wonderful. Next one is to condense. So that one was expanding. This one is now condensing. So we're going the opposite way. So I have this 2 out front and this 10 out front. I'm going to use the power rule and then put them back into the exponents here. So we're going to have log base 4. It's going to become x squared plus log base 4 y to the 10th. Okay, we're adding, which means when we combine them and condense them, we're going to multiply inside the log function. So since they have the same base, we can only do this if it's the same base. And they're both base 4, so we can. Since we're adding, it's going to be x squared times y to the 10th. And that's our final answer. Okay, over here, again, same thing. We're going to move our coefficient out front to our exponent using the power rule. So you get log base 6 of x to the 8th minus log base 6 y squared. And then this time, since we are subtracting, we're going to divide using the quotient rule. So we have the same base. Okay, this time instead of multiplying, right, the subtraction means we're going to divide x to the 8th divided by y squared. And there's our final condensed answer. So this is the exact same thing as the original. It's just written in a condensed form. 17 and 18 want us to solve. So right now, we can't solve these in exponential form, so we need to change them to log form. So again, if you have y, so this is written as b to the x equals y, right? And that's going to go to log, well, we could write it either way. Let's do it the other way. Let's say x equals log base b of y, right? So we have b, we have x, and we have y. So if we switch it around, we're going to have x equals log base 4 of 7. I'm going to round to the 10th place. So I'm going to put this in my calculator. Log base 4, 7. I'm going to hit enter, and it's going to give me approximately 1.4. So I actually isn't exactly 1.4, so I'm going to put a little squiggle for my equal sign. It's approximately 1.4. If I want to check my answer, again, I can plug it back in the other way, right? So I could do 4 to the 1.4. It gives me about 7, right? It's not perfect because we rounded, but it's about 7 because this answer is about 1.4. It's not exactly 1.4. All right, next one, we're going to do the same thing. So it's going to become x equals log, the base is 3, the y is 10. And then I'm going to put it in my calculator. Log base 3, 10. And you get 2.09. So I'm going to put 2.1 in. And again, if I go and check my answer, 3 to the 2.1, it should be about 10, right? If I use the whole thing, so if I said 3 to the, and I used all of this, it's going to be closer to 10. It's going to be exactly 10 right there, right? So it just depends how you round. All right, I'm not going to do all 6 graphs, but we can do a couple of them. Okay, so let's do the first one here. All right, so there's 3 basic steps. The first is we're going to do the asymptote. So our asymptote is x equals -1, right? So we have asymptote is going to be x equals, right? Because this is a shift left 1, which means our asymptote, instead of being x equals 0, it gets shifted 1 to the left, which is going to be x equals -1. Right? Normally it would be x equals 0 for a log function, but since this is shifted 1 left, it's x equals -1. Okay, that's step 1. Step 2 is we need the x-intercept. So to find the x-intercept, we're going to plug in 0 for x. So that gives us log base 6, x plus 1 plus 3. All right, and now we're going to solve for x. So I need to get this to exponential form. So I first need to subtract 3 on both sides. And now I can change it to exponential form. So it's going to be x plus 1 equals 6 to the -3. And then I subtract 1 on both sides. So I'm going to get x equals -1 plus 6 to the -3. That's going to be like -0.99 or something around there, but let's see. -1 plus 6 to the -3rd. Oh, whoops. Nope, that's not what we want. Control Enter. There we go. So, yep, -0.995. So x equals -0.995, which is very, very close. It's like right here, right? Very, very close to the asymptote. Right, and then that's step 2. So step 1, asymptote. Step 2, x-intercept. Step 3 is find any other point. I'm going to find 0.5, right? So if I draw my x, a little box here, again, you don't really need to do this, but I'm going to do it anyways. So let's see, I have -0.9950. And then for my next x value, I'm going to try 5, okay? Because I know that one's going to be a whole number, but you can try any point. Right, so let's see, we have log base 6. I did 5. So 5 plus 1. Oops, close the parenthesis, go forward, and then plus 3. That gives me 4. So my point here is going to be 5, 4. Right here. And that makes sense because our base is 6, so this should be increasing. So if I draw in my graph, right, that wasn't great. Let's start over. It's going to be very, very close, but not touching, right? And then it's going to look something like this. All right, so x and y intercept. So x-intercept we already have. We know the x-intercept is negative 0.9950. Y-intercept we don't have. So that one's easy. We can just plug in a 0 for x. So it's going to be log. We can actually just highlight this one. And then instead of a 5, we're going to plug in 0. So our intercept is 0, 3. Oops. Okay. So again, we got another point here. We can actually make our graph a little more accurate if we want now. So I think I'm going to do that. I'm going to erase this line. I know I have a point at 0, 3. So I'm going to go up, up, right? It's still going to go up, and then it's going to curve like this. You don't have to redraw it, but there you go. Okay, so we got asymptote, we got x and y intercept. We want domain. Okay, so our domain, the farthest left we can go is we approach -1. We don't quite reach -1, but we approach it. So we're going to put a parenthesis, -1. And then we go all the way to the right, which is infinity. Our range, we go all the way down to -infinity, or we approach -infinity, right? We can't actually get there. And then this is increasing very slowly, but it is increasing. So it will slowly, slowly, slowly get closer and closer to infinity. So -infinity to +infinity. And then end behavior. So as x approaches the right, it's approaching infinity. And as x approaches infinity, so does y. Okay, and then the other side, x approaches -1, right? It can't get to -infinity. It can only approach -1. Our y value is going to approach -infinity. So that would be all the information we have. Okay, let's do one more. I don't want to do all 6. We'll just do one more. We'll pick one going the other way. So let's pick, let's do 22. Okay. And just remember here, your base, right? You could rewrite this as y equals log base e x plus 5 minus 2, right? So your base would be e, but that's all right. Let's do 22. All right, step 1, asymptote. Let's pick, actually I lied. Let's do, they're all -1. Why are they all -1? Okay, that's fine. All right, well, those are positive ones. I wanted something a little different, but that's okay. All right, let's do 22. So this is a shift 1 left. So again, our asymptote, just like on our first one, is going to be x equals -1, right? So we can draw in our dashed line here at x equals -1. Okay, step 2 is find your x-intercept. So we're going to plug in 0 for y. So it's log 1/2 x plus 1 minus 5. We're going to add 5 to both sides. Okay, added 5 to both sides. So it cancels on this side. 0 plus 5 is 5. All right, now we can change it to exponential form. So we get x plus 1 equals 1/2 to the 5th. Okay, and then we're going to subtract 1 on both sides. So I get x equals 1/2 to the 5th power. This should really be in parentheses. And then minus 1. So let's see what we got. 1/2. 1 divided by 2. Oops, not 1 minus 2. 1 divided by 2. Okay, to the fifth power gives us 1 over 32 minus 1. It's going to give us negative 31 over 32, which is negative 1.97. So it's going to be x equals negative 1 point. Oh, no, it's not. No, wait. How do we get? Oh, it subtracted 1 twice. I'm sorry. Let's go back again. Let's try it again. So 1 divided by 32. Or let's just go all the way back. Okay, let's go in parentheses. 1 divided by 2 to the fifth, right? And then we're going to subtract 1, and I'm going to hit Control Enter. Negative 9.7. Okay, that makes more sense. Negative 0.97. Negative 0.97, which again is right here. Okay, so step 1, the asymptote. Step 2, our x-intercept. Step 3 is pick another point. So let's pick one more point. Okay, I'm going to pick a point over here. I'm going to say 6. Okay, so let's type it in. We have log base of 1/2. What did I say? 6. 6 plus 1. And then minus 5. I get negative 7.8. So 6 negative 7.8, which is right here. Okay, I'm also going to do my y-intercept. So let's plug in 0 for x, because we're going to need that anyways. So I'm going to do it again, except instead of 6, I'm going to plug in 0. And then the more points you put in, the more accurate your graph is going to be. So 0, negative 5 is right here. Okay, so when we graph this, we're going to hit this point. We're going to go through negative 5. And then we're going to go here. And there's our graph, right? We got an asymptote, x-intercept, one other point. I got 2 other points. That's fine. Okay, so let's fill in all our information. So our x-intercept, right, we said was negative 0.97, 0.97 comma 0. Our y-intercept was 0, negative 5. Okay, again, notice this is decreasing because that base was 1/2. Okay, asymptote is x equals negative 1. Domain, so the farthest left we can go is towards negative 1. We can't quite get past it, to infinity. Range, we can go all the way down, we can go all the way up, so it's negative infinity to positive infinity, right? We can't actually reach infinities. That's why we have parentheses. And then end behavior, right? On the one side, x is going to approach infinity, right, as it goes to the right. As x goes to the left, it's going to approach negative 1. So as x approaches positive infinity to the right, y is going to approach negative infinity. And as x goes to negative 1, y is going to go to positive infinity. Okay, so there's 4 other practice graphs there. You can check out the answer sheet if you want to see if your graphs are good.